Hello friends. Welcome to my channel Faisai. In this particular video and the subsequent videos, we will study a very important topic in atomic and molecular physics, so you can say in quantum physics, which is called LS coupling. Okay. Uh, LS coupling and this JJ coupling are applied on multi-electron atoms. Okay. So in a multi-electron atom, we have, suppose we have an electron. So some of the electrons are more bonded to the nucleus, and some are not that much bonded to the nucleus, and therefore there are bound electrons and some electrons which are, you know, very far away from the nucleus. They're called optically active electrons. Okay. Now these multi-electron atoms can have energies, can have interactions of these five kinds. First of all, the kinetic energy of the electrons. Okay, the electrons revolve around the nucleus, and due to that, they have kinetic energy. The electrostatic energy due to the interaction of the nucleus with the electron. Since nucleus is positively charged and electron is negatively charged, so there is a interaction between the nucleus and the electrons. The third thing is the mutual electrostatic energy of the electrons. The mutual electrostatic energy of the electrons means the electrons themselves can, they can repel each other. Okay. Also, they can have the orbital, magnetic moment due to their orbital motion around the nucleus. And then the spin-spin correlation energy, we know that electrons can spin clockwise or anti-clockwise. So the light, if they have parallel spins, then they can repel, and if they have anti-parallel spin, they can attract. And last thing is that is spin orbit magnetic energy. Uh, the the spin and the the orbital magnetic moment, they can interact with each other, and due to which the energy can be increase or decrease. Okay. So this the LS and JJ coupling is nothing but we have to find that which of these five terms dominates in a particular atom. Okay. Now let's see about the LS coupling. Now LS coupling is applicable for most of the atoms and especially the lighter ones. Okay. In these type of atoms, the effect of the third term, which is the third term, the third term is the mutual electrostatic energy of the electrons. This term, and then the fourth term, that is the spin-spin correlation energy term. These terms dominates over the rest of the terms. Okay. So due to which uh, what we get actually, that we have three steps. In step 1, okay. Oh, sorry, this LS coupling is also called Russell Saunders coupling. These were astronomers who very first time they used it in studying the atomic spectra. Okay. So step 1, in step 1, as a result of spin correlation effect, that is due to the third term, these spins of various electrons couple to each other. Okay, they couple to each other. Okay. Now couple to each other to form a resultant spin vector S. Okay, we have a resultant spin vector S, and S have magnitude of s into s plus 1 and then h cross h bar, you can say h upon 2 pi, it is h upon 2 pi. Now this is the step 1. Okay, now how these added up, we can take an example. Okay, for example, suppose we have two electrons. Okay, the first electron has a spin 1 by 2 and second electron has a spin 1 by 2. Okay, electron can have anti-parallel or parallel spins. Okay, we have two. So the number of s values will be, the value of s will be from s1 minus s2 to s1 plus s2. Okay, so from this we have the values from 1 by 2 minus 1 by 2, that is 0, to 1 by 2 plus 1 by 2. Okay, increasing by 1, increasing by 1. Okay, this is how the the spins of the various electrons, they couple with each other. Okay, so we have two values of s. Okay, now there is a thing which is called multiplicity. The multiplicity is given by the formula 2s plus 1. Okay, so the multiplicity of this will be equal to what? 1. It is called a singlet state, and the multiplicity of this is 2s plus 1, that is 2 into 1 plus 1, and that will be equal to 3, and it is a triplet. It is a triplet. Okay, so this is how we can also see the example of 3 electrons or 4 electrons. So if we have more than 2 electrons, we can use first we interact 2 electrons, and then we'll come to the this state, and we'll interact it with the third electron and come to the next state, and then we'll move on. Okay, now this was the second step. Okay, this was the first step. Okay, first we have to combine the spins. Okay, let us take an another example for 3 electrons. Okay, let's see. For 3 electrons, let's say s1 by 2, s2 1 by 2, s3 1 by 2. So these first two spins combine to form, let's say s dash, that is equal to 0 and 1. Okay, now this can interact with the s3. So we will have the values 1 by 2 minus 0. First of all, we will take this s dash is equal to 0 and s3 is equal to 1 by 2. So we'll have s is equal to 1 by 2 minus 0 to 1 by 2 plus 0, and so it will come as 1 by 2. Now we interact this with this, so we'll have s is equal to 1 minus 1 by 2, that is 1 by 2, and then 1 plus 1 by 2, that will become 3 by 2. So we'll have three values S1 by 2, this and this. So it is a doublet. Okay, I'll get the doublet, put this as in this, and we'll get the multiplicity. And this is also a doublet. It is a quartet. It is quartet. Okay. So this is how we can find the spin. Okay. Now now the state of highest S have the lowest energy. Okay, the state S have the lowest energy. Okay, which has highest S will have lowest energy. So from these two results we can see that when we have two electrons, this state has the lowest energy and this state has highest energy. From this we can see that this state has the lowest energy and these two states have the highest energy. Okay. So we can find in this way how the spin interacts. Okay. Now this is the first step. Now the second step. In step 2, the the third terms, that is due to the residual mutual interaction electrostatic energy of the electrons, we have the orbital angular momentum as a result of the residual electrostatic interaction the orbital angular momentum of various electrons electron means the orbital electrons strongly coupled to form orbital angular momentum vector L. Okay, so we have seen that in this step 1 the spins coupled to form a spin vector. Okay, and in this the orbital angular momentum of various electrons strongly coupled to form angular momentum vector L. Okay, the magnitude of L is L is equal to L into L plus 1 and then H bar. Okay. Okay. Now let us see an example. The values let us see an example how these can interact. Okay. suppose we have two electrons, that is one 3p and one 3d electron. These two electrons. Okay. For this electron we have L1, this is L1. Okay, we know this is p state, so L is equal to 0 1, S state, p state, d state, F state, and so on. So this is p state, so L1 is equal to 1, and this is d state, so L2 is equal to 2. Now the values of L goes from L1 minus L2, okay, in the steps of 1 to L1 plus L2 at last. Okay, so combining this will have two things. Okay, the values of 2 minus 1, it is 1, and 2 plus 1, it is 3, and we'll go we have to go in steps of 1, so we have L is equal to 1, 2, and 3. So we have three values of L. Okay, so this is a p state, this is a d state, and this is a F state. Okay, this is how we can combine, the orbital angular momentum of two electrons. Now let us take an example of three electrons. So let's say we have these three electrons, that is 2p, 3p, and 4d electrons. Okay, now for this L1 is equal to 1, L2 is equal to 1, and then L3 is equal to SPD, that is 2. Okay, now first of all these two will combine to make L dash. Let's say it is L dash. Okay, if it is L dash, then it goes from 1 minus 1 to 1 plus 1. So 1 minus 1 is 0, and then 1 plus 1 is 2, and in the step of 1 we will have these three values. Now these three values will interact with the this value, L dash value. So first of all we will take L dash is equal to 0 and L3 is equal to 2. So we'll have the values of L as 2 minus 0 to 2 plus 0. So L is equal to 2. ठीक है? Okay, so this is D state. Then L dash is equal to 1 and L3 is equal to 2. Okay, so we have 2 minus 1, that is 1, to 2 plus 1, that is 3. So we will have 1, 2, and 3. Okay, so what we have, this is P, this is D, and this is F state. Okay, now take L dash is equal to 2 and then L3 is equal to 2. So we will have this 2 plus 2, 2 minus 2, that is 0, and 2 plus 2 is equal to 4, and in the step of 1 we will have 1 and then 2 and then 3 and then 4. Okay, 5 states. So we'll have this state S, P, D, F, and G states. Okay, so this is how we can combine the spin, and in this we have combined the angular momentum. Now, now this step 3. Okay, this step 3. In this step 3, that is, this is due to uh, spin orbit magnetic interaction. The S vector and L vector couple to form J vector, which is called total angular momentum. Okay, which called total angular momentum, and whose magnitude is given by J into J plus 1 and then under root and then H cross. Okay, this is this step 3. Now in step 3, okay, then we'll have J is equal to L and then plus S. Okay, the magnitude of J as well as S and as well as C, that remains constant, and the magnitude of J is given by this. Okay, the J's take values, from L minus S to L plus S. Okay, in the next lecture or two, we'll discuss the problems of LS, this LS coupling. So we'll see how we can combine J's. Okay. Okay, the number of J's value, the number of J values is 2s plus 1. Okay, they are 2 plus 1 if L is greater than S, and the number of J values is 2L plus 1 if S is greater than L. If S is greater than L, it means that is due to spin orbit magnetic interaction, a level is characterized by given value of LS is further broken up into the comparatively closer 2s plus 1 or 2l plus 1 levels. Okay, so each is characterized by a particular J value. Okay, so these J values, these J levels forms a fine structure multiplet. Okay, the relative spacing, the spacing between these fine structure levels, it can be find by using the Lande interval rule. In the next lecture, we will study about the Lande interval rule. It is very important and very easy to find. So see you in the next lecture, and in the subsequent lecture we will discuss some very good and very very simple problems on this LS coupling. Till then, goodbye.